All right, so this is one of the story problems that was assigned to you for an assignment from chapter 4.2. It's the very last one in your 4.2 packet. We're determining the height of an aircraft. So it says here that we've got two sensors 700 feet apart along the approach to a small airport. So what this is describing is it's saying we have a sensor over here and a sensor a little further along down the airport. So they are 700 feet apart, and it says that we have an aircraft. When an aircraft is coming near, there's my aircraft. We'll give it a tail, we'll give it some wings, maybe some windows. There you go. We have this aircraft approaching the airport, and the first sensor that it sees is sensor A. And it says that sensor A makes a 20-degree angle with the ground. Boy, that's sloppy. Let's see what we've got here. 20-degree angle to the ground. Then it says that when it sees sensor B, and this is meant to give the plane a little bit of an indication of where exactly the runway is. So that one's 15 degrees. We have to figure out how high the aircraft is at this time. So we want to try and find out this distance right here. That would be measured perpendicular to the ground. Perpendicular to the ground is good news for us because that means that I have a right triangle over here, which means that I can use a little bit of SOHCAHTOA. However, I have a problem here. Even though I've got this 20-degree angle, I don't know any sides in that red right triangle. So I've got to figure out a side. I'm pretty sure that I can figure out this side. And if I do, I will have the hypotenuse to that triangle. So I'm going to turn my attention to this long skinny triangle over here. Why that long skinny triangle? Because I happen to know that in that long thin triangle, that side is the same as the hypotenuse in the red triangle. Good news. Now all I've got here is one angle and a side. But wait, I think I've got this angle as well, because I know that I've got a straight line here at A. Part of angle A is 20 degrees, so this one must be 160. Straight lines make 180 degrees. Well, if I know those two angles, I think I can figure out this angle. I would do 180 minus 160 minus 15 degrees. That's going to leave me with a 5-degree angle right here. That 5-degree angle happens to be directly across from that 700 feet. So I can write sine of 5 degrees goes with 700 feet. Now, what was the side I'm looking for again? Oh yeah, that one marked X. So that one marked X is directly across from 15 degrees. So I will write sine of 15 degrees over X. I can take that cross multiply. I'll have sine of 5 degrees times X equals 700 times the sine of 15 degrees. Then I'll divide both sides of that equal sign by sine of 5. And this is going to get me to solving for X. So grab my calculator, quickly punch out 700 times the sine of 15 degrees divided by the sine of 5 degrees. I've got 2,078, and we'll call that 0.7 feet. So that number goes with X over here, 2,078.7 feet. That happens to be the hypotenuse in this right triangle. The question mark is on the side opposite of the 20 degrees that I know about. So now what is it that I want to do? I want to write sine of 20 degrees equals the opposite, which is where my question mark is, over the hypotenuse, 2078.7. So I'll go 2078.7 times the sine of 20. That's going to get me my question mark. Grab my calculator, calculate that really fast. 2078.7 sine 20. There you go, 710.96 feet. Did it. So that airplane is 710, almost to 711 feet up off the ground. My final answer. Hopefully that helped a little bit. Thanks for listening. Bye-bye.